Seeing this scene, you might think that a bunch of locks are used and that the high-voltage electric shock is quite intense. In reality, no such high voltage is involved. The person inside the Faraday cage remains unharmed, and even touching the metal mesh of the cage won't result in an electric shock. It looks like magic, but it's actually the amazing principle of the Faraday cage. It was invented by the British physicist Michael Faraday. In simple terms, a Faraday cage is a structure made from metal or other conductive materials designed to protect the contents inside from external electromagnetic interference. How does it achieve this? Because a voltage difference can lead to electric shock, the outer shell of the cage is at the same electrical potential. When an external electric field affects the Faraday cage, the metal shell rapidly induces a charge opposite to the external field. These charges redistribute on the metal surface, creating an equal potential region inside the cage. The charges induced on the metal surface flow along the metal and are grounded to the earth, thus shielding the interior from the external electric field. Inside the cage, there is no potential difference between the cage and a person inside it, so no current flows through the body, thus avoiding the risk of electric shock. In the video's opening scene, the electrician is not inside the Faraday cage. Why doesn't he get shocked? It's not just about wearing insulated gloves. The electrician is dressed in protective clothing, specifically an equipotential high-voltage shield suit, which includes clothing, a hat, gloves, and socks. All these parts must be connected to form a complete, conductive protective shield around the body, similar to the Faraday cage principle, ensuring no electric shock. The Faraday cage principle also protects electronic devices from electromagnetic interference, making TV antennas, radar, and even MRI machines in hospitals operate more clearly. Even our everyday cars, though they look like mere metal shells, become mobile Faraday cages during thunderstorms. If lightning strikes the car, the electric charge will flow along the car's exterior to the ground, just like water flowing through a drain. It's worth noting that the Faraday cage principle is closely related to the phenomenon of electromagnetic induction. When an electrically neutral object is placed near a charged object, the charges will move. This was one of the phenomena Faraday discovered while studying electromagnetic induction. Through his extensive research on electromagnetic induction, Faraday not only invented the Faraday cage but also made significant contributions to the development of electromagnetism.